let us take up the next concept. Now we have handled 2 points. Now let us take 3 points, and let us say those 3 points lie on a line. And given that the point P cuts the line segment AB in the ratio m is to n, our goal is to know the coordinates of point P. This will give us the section formula. So this is the graphical representation of the points. So there is a line segment AB, and point P cuts this line segment in the ratio m is to n. How will you find the coordinates of point P? This is a question. Let us bring in our coordinate system. So let the coordinates of A and B are x1 and y1 and x2 and y2. The coordinates of A are x1, y1, coordinates of B are x2, y2. I do not know what is P. Let us assume the coordinate, it has some coordinates which are x and y. Okay. So let us bring in them in the coordinate system, which is this. Let us try to understand this particular coordinate system by putting up some triangles around. So what I have done is, I have actually constructed 2 triangles using the same logic that I used in the distance formula. If the coordinates of point P are x comma y, then I will construct a right angle triangle in this direction, where the x coordinate will be x and y coordinate will be the coordinate of y coordinate of A, that is y1. Similarly, I will do a same thing with respect to point B. I will drop a perpendicular which will meet at this particular point. So basically, I will drop a perpendicular which will meet the x axis, and again I will draw a perpendicular here. But let us, for sake of simplicity, we have constructed a right angle triangle where the y coordinate of this point will be y and the x coordinate of this point will be the x coordinate of point B, which will be x2 comma y. With this understanding, we can proceed further and see that the triangles, these 2 triangles are similar to each other. How? First of all, let us see, this line is parallel to x axis and this line is parallel to x axis as well. Therefore, these 2 are parallel lines, and this is a transversal that is passing through these 2 parallel lines. Therefore, these 2 angles, the angle A and angle P, will be same or equal. Next, these 2 are right angles. Then we know the sum of the angles in a triangle is 180 degrees. Therefore, this angle B must be equal to angle P. Therefore, triangle AQP must be similar to triangle PRB by angle test. That essentially means I have their sides in some ratio, correct. So, for simplicity, I have plotted these points with some coordinate references. So, this is A is 2 comma 2, B is 8 comma 8, then whatever I mentioned, the coordinates of Q are x comma 2 and coordinates of R are 8 comma y. So, now these 2 things will be in some ratio, that is AP by PB, AP by PB, these are the hypotenuse of these 2 right angle triangles, is equal to AQ by PR, and this thing is QP by RB, right, or you can say AP by PB is equal to AQ by PR, which is equal to PQ by BR. Now, I already know AP by PB have a ratio m is to n. So, their ratio is m by n, that is already known to us, that is given to me. Now, can I calculate the length of AQ and PR? The answer is yes, because AQ is parallel to x axis, it is just subtracting the highest x coordinate from the lower. So, it will be x minus 2 in the figure, and in our theory it is x minus x1. Similarly, you can look at PR, it will be 8 minus x, or in our theory it will be x2 minus x. For y axis or the lines that are parallel to y axis PQ and BR, you can see you will go to the highest value, that is y minus 2 or y minus y1, and the other one BR will have y2 minus y. Right. So, together I will have a representation of this form: m by n is equal to x minus x1 upon x2 minus x, which is equal to y minus y1 upon y2 minus y. Now, take one equality at a time, that means m by n is equal to, let us say this, consider these x coordinates. So, just cross multiply them, rearrange them, you will get what x is equal to. In a similar manner, just take m by n is equal to this y coordinates ratio, and then cross multiply and rearrange them, you will get the following values, which are given by x is equal to m times x2 plus n times x1 upon m plus n, and similarly y is equal to m y2 n y1 upon m plus n. This gives me the section formula when a point divides the line in the ratio m is to n. Another interesting question is, suppose I know the coordinates of x and y, can I find in what ratio the line divides? Obviously yes, because you know the coordinates of the line, you just need to use this formula for finding the ratio. Okay. That will be more clear when you solve more problems.